Hello, this is Mr. Miller. Welcome to video 2A. We've entered Unit 2. And the title of this video is Introduction to Limits. We're going to be looking at a bunch of graphs of functions and trying to see what they're approaching. Alright, here's the first couple of examples. We want to talk about limits from the left, from the right, and from both sides. So here's our first graph right here. This is our function f of x. And our job is to make sense of this expression right here. And I know it's going to be a little bit hard to maybe see, especially if you're using a phone. I'll try to explain what it means. First, there's LIM. That stands for limit. And f of x is the function we're talking about, this function. And below the word letters LIM, there's a symbol that goes x and has an arrow that says 1 minus. What this is talking about is it's asking what is the function approaching as x approaches 1 from the left. The negative is like the left side of the number line, right? So we're talking about as we consider x values that approach 1 from the left, what is the function approaching? So as we go along this curve here, we see that the function is approaching this value right here, 1. At 1, there's a hole there, which means it's not actually equal to 1. But as x approaches 1, this graph approaches the value of 1. So this first answer is just 1. Now, this symbol right here says the limit of f of x. It's a little hard to see, but underneath the limit it says as x approaches 1 with a plus. That means from the right side. The positives are on the right side of the number line. So as we let values of x go this way towards 1, what is the function approaching? Well, when x is 3, the function is 2. When x is 2, the function is 2. In fact, it's 2 all the way down to 1. So again, this is what it's approaching as it gets closer to 1. We actually don't care what it is at 1. It's what is it approaching from the right. So as we approach from the right, it's 2 all the way, and it approaches 2. Now, this third one is a limit just as x approaches 1. That's kind of from both sides. And in order for this limit to exist, they have to approach the same thing. As we approach from the left and from the right, in order for the limit to exist, they have to be the same. They're not the same in this case. From the left, where the function approaches 1, from the right, it approaches 2. So I'm going to put D and E right here. It does not exist. All right, f of 1 is actually asking for the value at 1. That exists. At 1, the solid dot indicates that the value of the function is 2. So the limit is about what the function approaches as x approaches a certain value. And again, it doesn't matter what the function actually is at that value. It's what it's approaching. All right, let's try this example here. So on this one, it's asking the limit as x approaches 1 from the left. So as we kind of cruise down here and we approach to where x equals 1, we see that y approaches this value right here, which looks like it's a little bit less than -1, maybe -1.1 or something. So I'm going to put like -1.1. I can't really tell for sure, but it's less than -1. Then, what is it approaching as we approach 1 from the right? Well, from the right, we're following this piece of the function. And it looks like it's approaching 1. As we get closer and closer and closer here to x equals 1, the function is getting closer and closer and closer to 1. Okay, now, the limit as x approaches 1, that means from both sides. So, well, again, it doesn't approach the same thing from both sides. So we're going to say D and E does not exist. In order for it to exist, it has to approach the same thing from the left and right. Now, the actual value at 1 was this, 0. That's where the solid dot is. Okay, so the purpose of this video is kind of see several examples of graphs and limits and get a kind of feel for what's going on. Here we go. On this function, this is f of x here, and we're approaching from the 1 from the left. Okay, so again, the symbol that's right here, if it's hard to read, is x approaches 1 from the left, 1 minus. From the left, okay, as x is approaching this way, where x values approach this way, this is what the function's doing. It's negative, then it turns positive, and then it approaches this value, 1. From the right side, as we consider values of x that approach from the right side, approach 1. The function's coming up here, as we get closer and closer to 1, it approaches the same point as before. So finally here we have an example where it approaches the same thing from both sides. So we can say the limit as x approaches 1 from both sides is 1. Usually you don't say the words both sides. Just when I say the limit as x approaches 1, that means from the left and from the right. Okay, f of 1, the actual value is not even defined. There's no point at 1, so this is not defined or undefined. Alright, this is almost the same thing, except this time we have a point here. So, as x approaches 1 from the left, it's the same thing. Function approaches 1 from the right, 1. From both sides, just the limit in general as x approaches 1 is 1. But this time we have a value. This time, at 1, the actual value of the function is negative 2. So that was almost the same thing. Let's see what we have here. So here's some more functions. Okay, this time we're doing the limit as x approaches 0 from the left. Okay, alright, so we're approaching 0, so we're going towards the y-axis here. So as we approach from the left, the value is 1. Guess what? As we approach from the right and kind of follow the function up here, it approaches 1. Since the limit exists on both sides and approaches the same thing, we say the limit as x approaches 0 of f of x is 1. And in fact, the actual value of the function is 1 also. Alright, this time, this is an asymptote here, so we gotta be careful here. Alright, the first limit is x approaches 2 from the left. So as we approach 2, we're approaching that vertical asymptote. Well, as we approach from the left, the value of the function is going to go to positive infinity. So we could say plus infinity. That really is not a number. So that really doesn't, it's not a number, it doesn't exist. But so it's going to infinity. And then here, as we come from the right, so the symbol was x approaches 2 from the positive side, from the right. Well, our function goes big and negative without bound. So anytime a limit approaches infinity, it's another case of it not existing. So those really didn't exist either. But sometimes I say plus infinity, so we know it's increasing without bound. Negative infinity, so because it's getting negative without bound. Altogether, the limit doesn't exist, and neither does f of 2. The function is not defined there. 2 is not in the domain. All right. What do we have here? So again, 2 from the left, 2 from the right. Well, as we approach, negative 2 from the left and the right, as we approach negative 2, from either side, the limit is, or the function is approaching positive infinity. It gets bigger and bigger that way. So infinity, infinity, I guess we could say altogether it's approaching infinity since it's doing the same from both sides. But that's another case of does not exist. Infinity is not a number. And at negative 2, function does not exist. Alright, this thing's almost the same thing, except they actually gave it a value at negative 2. So from the left, this branch is still going to infinity. From the right, this is still going to infinity. So the whole limit is going to infinity, which again does not exist. And at negative 2, they put a point there, so it actually has a value. The value is 0. Okay, so there are several ways that limits can't exist. We'll see it as we go along. All right, so we'll have a couple quick examples from the book. This just says limit as x approaches 1. Well, it's what it approaches from both sides. So as we approach from the left, you see it approaches 3. And as we approach from the right, it approaches 3. So since it approaches 3 from both sides, it equals 3. Look at this one. The limit as x approaches 1, this value right here. Well, as we approach from the left, the function is getting closer to 3. And as we approach from the right, it's getting closer to 3. Doesn't matter what the actual value is, it's what it's approaching. So this would be 3. Okay, hopefully you're kind of getting a feel for this. It says find the limit. Oh, this is not going to exist because there's an asymptote there. So from the left, as we approach 3, from over here, this is going down to negative infinity. And as we approach, x gets closer from the right side, it's approaching positive infinity. So this does not exist. Okay. What else do we have? All right, we have one crazy last one. Okay, then we're done with the example. So f of negative 2. So that's the actual value of the function at negative 2. It doesn't have a value. It has an asymptote there. So it does not exist or not defined. This says the limit as x approaches negative 2. Well, it goes to negative infinity here, positive infinity there, so it does not exist. Okay, what's f of 0? All right, that actually has a value 4. The limit as x approaches 0. Well, as we approach from this way, it looks like it approaches about a half. And as we approach from the right, it's 4. So since it's not approaching the same thing on both sides, another d and e. Okay, f of 2. F of 2, there's actually no point at 2. So another d and e does not exist or not defined. As the limit as x approaches 2 of f of x, this one, as we approach 2 from the left, looks like it equals 1/2. And as we approach from the right, looks like it equals about 1/2. So that limit exists. It's the y value of this point. Finally, at f of equals 4, this is the actual value of the function. It's 2. But the limit doesn't exist. As we approach 4 from the left and from the right, it's positive infinity, which again is not a number. The limit does not exist. Wow. Okay, so at least hopefully this gives you a little feel. This is kind of a big step. What are we talking about limits? We have limits from the left, limits from the right. When they both exist, we say the limit exists as x approaches that point. So this will take a little getting used to, but after you do some examples and try it on yourself, by yourself, it's not too bad. All right, so here's a journal assignment for you. And on this first function, you're just going to find the limit as x approaches 1 from the left. That's 1 minus. X approaches 1 from the right. And then this is just the limit as x approaches 1. I don't know if you can see those. And this one they're talking about as x approaches 2. So x approaches 2 from the left. What's the limit as x approaches 2 from the right? And just simply, what's the limit as x approaches 2? All right, we'll do more in class. Good luck.